Hello, my dear students. Welcome back to my channel. In the continuous process of discussing the PYQs on class 12th mathematics CBSE, today I am with a new problem which has been asked in CBSE board examination 2023. The problem relates to relations and functions. So the problem is if n denotes the set of all natural numbers and R with a relation on n Cartesian product n defined by ordered pair relates to CD if AD plus C is equal to BCA plus D. It is the punchline of the relation to show that R is an equivalence relation. So this is all about this problem which has been asked in 2023 CBSE board examination. So how to tackle this problem? Let us see. We have to prove that this relation is an equivalence relation. For this, what we have to show? We have to show that this relation is reflexive, symmetric as well as transitive. If we are able to show that the relation is reflexive, symmetric and transitive, then it will be clear that the relation is an equivalence relation. So for the reflexivity, we will check firstly about the reflexivity, whether this relation is reflexive. So for this, if we are able to prove that ordered pair AB relates to ordered pair AB, then it will be clear that this relation is reflexive because this ordered pair AB is an arbitrary ordered pair. It consists of from the arbitrary elements A and B. A and B both belong to the set of natural numbers. So this is arbitrary ordered pair. So what we have to show, if this is going to be related with the same, that is A comma B relates to A comma B, then what will happen? So here A comma B relates to C comma D. So what will happen? ADB plus C. So whether this is true, ADB plus C. So in this way, AB, here is AD, here is AB, B plus C, this. So it will be this AB, B plus A is equal to, whether this is equal to BC A plus D. So BC here is BA, and here is A plus D. So here, whether this, if this ordered pair is relates to itself, then this is going to be true. So here is ABB plus A is equal to BA plus B is absolutely true, because the natural number follows the commutative law of addition as well as the commutative law of multiplication. For the natural numbers, as A comma B both belong to the set of natural number, and here the commutative law of addition and multiplication holds. So you can write this BA as AB, B plus A is equal to AB. Here you can write B plus A. Here you can write B plus A. So this is same. It is equal to this. It is obvious. So A comma B definitely relates to A comma B. And if this happens, as A comma B is an arbitrary ordered pair, so it is true for all other ordered pairs also, which belong to the set n by n Cartesian product n of the Cartesian product of the set of natural numbers. So this is going to be true. So that's why this relation is reflexive. Now we'll check about the symmetricity, whether this relation is symmetric or not. We will do this here. So symmetricity. What about symmetricity? So for symmetricity, we will consider that let A comma B relates to C comma D, and if we are able to prove that C comma D also relates to A comma B, then the relation will definitely be symmetric. So if A comma B relates to C comma D, then it is given in the question. Then ADB plus C, then AD B plus C is equal to BCA plus D. So for the sake of simplicity, we can write first what we have to gain, what we have to find previously. We have to write it for the sake of convenience. So what we have to prove that CD relates to AB. CD relates to AB. If AB relates to CD, then what we have to show? CD relates to AB. And this is, if this is going to be true, then what we have to prove? We have to prove. We have to show that. What we have to show that CD relates to AB. So here AB. So here is AD. So here will be CB. CB D plus A, D plus C, CB D plus A is equal to BC. So here is DA, here is DA, and here is A plus D. So here will be C plus B, C plus B. Here will be C plus B. Here will be A plus D at this point. So here will be C plus B. So we have to prove this from this relation. So it is very obvious if we write BC A plus D here in the left hand side and ADB plus C in the right hand side, then we will approach towards the result. So we can write this one as, we can write one as BC A plus D. BC A plus D is equal to AD B plus C. So, and as the natural numbers obeys commutative law of addition as well as multiplication, so we can write BC as CB, and A plus D as D plus A. Okay, and what AD as DA and B plus C as C plus B, with the help of commutative law. With the help of commutative law in natural numbers. So it is obvious that if we are able to prove that CB D plus A is equal to DA C plus B, and this, if this happens, then CD relates to AB. CD relates to AB. So it is clear that the relation is symmetric. So it is clear that the symmetricity holds. Now what about the transitivity? What about the transitivity? Transitivity. So for transitivity, we will consider that let A comma B relates to C comma D, and C comma D relates to E comma. We will consider this. So if A comma B relates to C comma D, then with the help of this, we can write AD B plus C is equal to ADB plus C is equal to BC A plus D. So, and from this we can write, from this, it is an important point. Please note it. What we have to do, we have to, as we have to find that whether AB relates to EF, then the relation will be transitive. So what we have to do, we have to transfer this BC on the left hand side and transfer AD on the right hand side, and it will be in the denominators on both the sides. So B plus C upon BC is equal to A plus D upon AD. We can write it 1 upon C plus 1 upon B, 1 upon C plus 1 upon B is equal to 1 upon D plus 1 upon A. Okay, this is equation number 2. This is equation number 2. And if this happens, CD relates to EF. So with the help of same situation, we can write it CD relates to EF. So AD, that means CD relates to EF, then CD, AD. So CF, here is AD, so here will be CF. If CD relates to EF, so CF D plus C, here is B plus C, so CF D plus C is equal to CF D plus C, and here will be BC A plus D. So in this way you can write DE, and here is A plus D. So here will be C plus F. Here will be C plus F. So we can write it, we can definitely write it D plus E upon DE is equal to D plus E upon DE is equal to C plus F upon CF. You can write it 1 upon E, 1 upon E, 1 upon E plus 1 upon E plus 1 upon D plus 1 upon D. 1 upon E plus 1 upon D is equal to 1 upon F plus 1 upon C. It is equation number 3. Let us follow it. What we have to do next? We have to add these two equations. What we have to do? We have to add these two equations. We will write something here. We will write here. So when we add 1 upon C plus 1 upon D plus 1 upon E plus 1 upon E plus 1 upon D, left hand side, and 1 upon D, 1 upon D plus 1 upon A plus 1 upon A plus 1 upon F plus 1 upon D plus 1 upon A plus 1 upon F plus 1 upon C plus 1 upon C. Okay. So what cancels out? It is 1 upon D and 1 upon D on both the sides, and it is one more thing will cancel out. It will be 1 upon C, 1 upon C, and 1 upon C from both the sides. So what we will get? We will get 1 upon B plus 1 upon E is equal to 1 upon A plus 1 upon F. You can write it. You can write it after taking the LCM. After taking the LCM, you can write E plus B upon BE is equal to F plus A upon AF. F plus A upon AF. You can write it AF E plus B is equal to BE. AF E plus B BEF plus A. What we have to show that AB relates to AB, AB relates to EF. You have to show that AB relates to EF. So if AB relates to EF, AB relates to EF, then according to this relation, what you have to prove that AF B plus E, AF B plus E in the same way as AD B plus C is equal to BC, that is here is BE, here is BE and A plus F, BE plus A plus F. So what you are getting here, AF B plus E. So you can write by the commutative law that it is AF B plus E, and by the same law it is BE, it is BE, it is BE, and here will be A plus F. So it is clear that if this relation holds, then A comma B relates to E comma F. So the relation is definitely transitive. Transitivity is justified. So in this case, here in this question which has been asked in 2023 CBSE board examination, it is clear that the relation is reflexive, symmetric, as well as transitive. That's why this relation is going to be an equivalence relation, what we have to prove. So this is the way to solve this type of question. This is for today. Thank you very much.